This is a video for Module 1. This is a second video. In the last video, we had started Example 1 where we went through the basic vocabulary. We're going to now finish Example 1. So in Example 1, we had asked whether or not our die is fair. In other words, we wanted to know if the die was rolling fives a sixth of the time in the long run. We want to know if the population parameter is equal to pi equals 1/6. Now, we can't possibly roll the die over and over forever, so we took a sample of 60 rolls. We found our sample statistic was p hat equals 14 out of 60. In other words, our die rolled fives 23% of the time in our sample. So the question then is our sample, where we got 23% fives, enough evidence for us to say, wow, that's really a lot higher than 1/6 of the time, so we will conclude that it's not a fair die? Or would we conclude that, rolling fives 23% of the time is, close enough to 16% of the time, to 1/6, that, yeah, that's a normal, usual, expected sort of thing to get if the die is fair? How do we make that sort of decision? Well, the way that we do this in statistics is we're going to create what's called a chance model. We're going to create a model that shows us what we should expect if the die is fair. If the die is really rolling fives a sixth of the time in the long run, then we're going to see a visual display that shows us what sort of statistics we should get if we roll the die 60 times. Then we'll compare the statistic we actually observed, which was 14 out of 60, with our chance model and see if it's in the area of usual, normal, and expected, or if it's an unusual sort of thing to get. All right, so I have a little bit of reading here in the lecture guide, so let's just go through that and then we'll answer the next question. It says, if we conduct a sample, then which sample statistic values are usual versus unusual statistics to get if our die is actually fair? In order to figure that out, we could roll a fair die 60 times and record the proportion of times that it rolls a 5. Then we could repeat that. We could roll it again 60 times and record again. We could record how many times it rolls a 5 that time. Then we could repeat it and do it again. Roll it another 60 times and record how many times it rolls a 5. If we did that over and over, we would start to get a really good picture of what we expect to happen with a fair die. In this way, we would be able to get an understanding of the sort of sample statistics that are normal and usual and expected if the die's fair, and then we'll compare them to our observed statistic. But, that would be very time-consuming to roll the die 60 times, and then roll the die 60 times again, and then roll the die 60 times again. We can't do that. That would take forever. So instead, we use a computer simulator to do that for us. All right, so at this time, I am going to